Welcome to Math with Mr. J. In this video, I'm going to cover comparing and ordering decimals. We will start with comparing and then move on to ordering. And then lastly, I'll give you some practice problems that you can try on your own. So as far as comparing decimals, let's jump into number 1, where we are comparing 25 hundredths and 6 tenths. Now, please keep in mind, we can't automatically say that 25 hundredths is greater because it has more digits or because 25 is greater than 6. It doesn't work that way when it comes to decimals. The length of a decimal, the number of digits, does not determine which decimal is greater. We have to compare the place values. So first, what we need to do is line up the decimal points. So we have 25 hundredths and 6 tenths. Lining up the decimal points lines up all of the places. So we have zeros in the ones place, a 2 and a 6 in the tenths place, and then a 5 in the hundredths place. Now this may look a little off since it's offset. This is because our decimals go to different places. So what we can do, we can use placeholder zeros. Remember, zeros to the right of decimal digits do not change the value of the decimal. So they give us an equivalent decimal. So we're able to do this. Since 25 hundredths goes to the hundredths place, let's use a placeholder 0 here. That way, this decimal goes to the hundredths place as well. Now this looks a little more lined up and neater. It can also help us compare. Once we have our decimal points lined up and we use placeholder zeros, we compare digits from left to right. We go place by place comparing digits. We start at the furthest place to the left because that's the greatest place value, and we work our way right. So here, starting to the left, we have zeros in the ones place, so no whole numbers. Since both of these do not have whole numbers to compare, we move to the next place to the right. The tenths place. We have a 2 and a 6. So is there a difference here? Can we compare? Yes, 6 is greater than 2. So this is greater. The tenths place is a greater place value than anything to the right. So any digits to the right of the tenths place do not impact this comparison. So we were able to compare these decimals based on the tenths place. Now I do want to mention another way to think about this. We can think in terms of the entire decimal since they both go to the hundredths place. We have 25 hundredths and 60 hundredths. 60 hundredths is greater than 25 hundredths. And since 60 hundredths is equivalent to 6 tenths, we know that 6 tenths is greater here. Now remember, our comparison symbol always opens up towards the greater value. So it goes like this. And we can read this comparison from left to right as 25 hundredths is less than 6 tenths. Let's move on to number 2, where we are comparing 72 hundredths and 72 thousandths. Let's line up the decimal points. So 72 hundredths and 72 thousandths. Since 72 thousandths goes to the thousandths place, let's use a placeholder 0 right here. That way, both decimals go to the thousandths place. And now we can compare. So we are going digit by digit from left to right, starting with the greatest place value. So we are starting from the left. We have zeros in the ones place, so we don't have any whole numbers to compare. Let's move to the right to the tenths place. We have a 7 and a 0. 7 is greater than 0. So this is greater. And we can also think in terms of the whole decimal here since they both go to the thousandths. We have 720 thousandths and 72 thousandths. 720 thousandths is greater than 72 thousandths. So for our original comparison, 72 hundredths is greater. We can read this from left to right as 72 hundredths is greater than 72 thousandths. Moving on to number 3, we are comparing 1 and 529 thousandths and 1 and 523 thousandths. Let's line these up. So 1 and 529 thousandths and 1 and 523 thousandths. Both of these go to the thousandths place, so we don't need any placeholder zeros. So let's start comparing digits from left to right. The greatest place value, the place furthest to the left, is the ones place. So let's start here and work our way right. Now for number 3, we do have whole numbers here, but we can't compare. We have the same number. We have ones. So we need to move to the right to the tenths place. Can we compare here? Is there a difference? No, we have fives, so we can't compare the tenths place. Let's move to the right to the hundredths place. Do we have a difference here? Can we compare? No, we have the same digit, 2. So let's move to the next place to the right, the thousandths place. Can we compare here? Do we have a difference? Yes, we have a 9 and a 3. 9 is greater than 3. So this is greater. And we were able to compare using the thousandths place. So our comparison symbol goes like this, and we can read this from left to right as 1 and 529 thousandths is greater than 1 and 523 thousandths. Next, let's move on to number 4, where we are comparing 4 and 3 tenths and 4 and 300 thousandths. So let's line these up off to the side here. So 4 and 3 tenths and 4 and 300 thousandths. 4 and 300 thousandths goes to the thousandths place. So let's use placeholder zeros after 4 and 3 tenths. So that goes to the thousandths place as well. Now you may notice these are equal. We have the same exact number, the same exact digits. We have a 4 in the ones place, a 3 in the tenths, a 0 in the hundredths, and a 0 in the thousandths. So these are equal. 4 and 3 tenths is equal to 4 and 300 thousandths. These decimals are equal in value. And remember, like we talked about earlier, zeros to the right of decimal digits do not change the value of the decimal. So we can even take these zeros off of the end here because they are not changing the value at all. So we can also look at this as 4 and 3 tenths is equal to 4 and 3 tenths. Next, let's move on to number 5, where we are comparing 2 and 1 tenth and 1 and 9 tenths. Let's line these up. So 2 and 1 tenth and 1 and 9 tenths. Both of these go to the tenths place, so we don't need any placeholder zeros. So now let's compare digits. We will work our way from left to right. We'll start with the ones place, where we have a 2 and a 1. So we are comparing the whole numbers here. And this is an important example because we are starting with the whole numbers. Don't skip the whole numbers and go straight to the decimals in case we have a difference, like we do here. We do have a difference. We can compare the whole numbers. 2 is greater than 1. So this is greater. 2 and 1 tenth is greater. So reading this from left to right, 2 and 1 tenth is greater than 1 and 9 tenths. Lastly, let's move on to number 6, where we are comparing 487 thousandths and 49 hundredths. Again, remember the length of a decimal, the number of digits a decimal has, does not determine which decimal is greater. So let's line these up and see what our comparison is going to look like. So we have 487 thousandths and 49 hundredths. Let's use a placeholder 0 here, so both decimals go to the thousandths place. And now we can compare digits. We will work our way left to right, starting with the greatest place value, the ones place here. We don't have any whole numbers, we just have zeros, so we can move to the tenths place. Do we have a difference here? Can we compare here? No, we have the same digit, 4. So we need to move to the right to the hundredths place. We have an 8 and a 9. So we can compare here. 9 is greater than 8. So this is greater. And we were able to compare these decimals by looking at the hundredths place. So 49 hundredths is greater. And we can read this comparison from left to right as 487 thousandths is less than 49 hundredths. So there you have it. There's how to compare decimals. Let's move on to ordering decimals. Now let's take a look at how to order decimals. And you'll notice this is going to be similar to comparing decimals. We're just going to have more decimals to work with. We'll go through two examples. One where we order from least to greatest, and one where we order from greatest to least. Let's jump into number 1, where we need to order the decimals from least to greatest. Now, the first thing that we're going to do to help us order these is line them up off to the side, and we're going to line up the decimal points. This is going to line up all of the places. So let's line up all of these right here. So we'll start with 1 and 3/10. Then we have 75 hundredths. Then we have 1 and 252 thousandths. Next, we have 1 and 295 thousandths. And then lastly, we have 8/10. Now this does look a little off since we have numbers going to different places. So what we can do, we can use placeholder zeros. Remember, zeros to the right of decimal digits do not change the value of the decimal. It gives us an equivalent decimal, so we can do this. We need to find the decimal that goes to the furthest place to the right. That's going to be the thousandths place. Here and here. So let's use placeholder zeros to the right of the other decimals to make them go to the thousandths place as well. So for 1 and 3/10, we need a placeholder 0 here and here. For 75 hundredths, we need a placeholder 0 here. And for 8/10, we need a placeholder 0 here and here. Now this looks a little more lined up and neater, and this will help us order. So now we move on to comparing digits from left to right. So we can start putting these in order. So we'll start with the place furthest to the left, and we will work our way right. The place furthest to the left here is the ones place. So that's going to be our greatest place value. We have 1, 0, 1, 1, and 0. So we want the smallest digit in value here since we are going from least to greatest. That's 0. So we have this narrowed down to these. Since those digits are the same, we go to the next place to the right to compare. That's going to be the tenths place. We have a 7 and an 8. So we're comparing the tenths place of those two decimals to see which is going to be the least. So having a 7 and an 8, we know that 7 is less than 8. So this is the least. So let's write 75 hundredths first here. And I wrote the decimal from the original list, again 75 hundredths, not the equivalent decimal with the placeholder 0, 750 thousandths. Now again, those are equivalent, so either will work, but I'm going from the original list. Then we can put a comma and cross this off. Now, before moving on, I do want to mention another way to think about this. We can think in terms of the entire decimal part here. We have 750 thousandths compared to 800 thousandths. 750 thousandths is less than 800 thousandths. Now back to what we have remaining, and we start the process over. So starting in the ones place, we have a 1, a 1, a 1, and a 0. Well, 0 is the smallest in value, so that comes next because we only have one number with a 0 left in the ones place. That's going to be this right here. So let's write the original number here, 8 tenths, and we can cross this off. Let's continue on. Looking at the ones place, we have all ones now. So we can move over to the tenths place. We have 3, 2, and 2. Those 2's are less than 3. So we have this narrowed down to these right here. Both have a 2 in the tenths, so we need to move over to the next place, the hundredths place, and compare those digits. We have a 5 and a 9. 5 is less than 9, so that comes next. 1 and 252 thousandths. And we can cross this off. Now, another way to think about that, we could have thought 252 thousandths compared to 295 thousandths. 252 thousandths is less than 295 thousandths. Now we are down to our last two decimals. So let's compare digits. We have ones in the ones place. So let's move over to the tenths. We have a 3 in the tenths and a 2 in the tenths. 2 is less than 3, so 1 and 295 thousandths comes next. So we can cross this off, and we are down to our last one, 1 and 3 tenths. So that comes last. And let's cross that off to show that we are done with everything here. We have all of our decimals in order from least to greatest. Now let's move on to number 2. So here's number 2. We need to order the decimals from greatest to least. Let's start by lining up the decimal points. So we are going to line up all of these. So we'll start with 2 and 972 thousandths. Then we have 2 and 6 tenths. Then 1 and 51 hundredths. Then 2 and 99 hundredths. And then 1 and 6 tenths. Now this does look a little off since we have numbers going to different places. So just like number 1, we can use placeholder zeros. Remember, zeros to the right of decimal digits do not change the value of the decimal. So we can do this. We need to find the decimal that goes to the furthest place to the right. That's going to be 2 and 972 thousandths. That goes to the thousandths place. So let's use placeholder zeros to the right of the other decimals to make them go to the thousandths place as well. So for 2 and 6 tenths, we need 2 placeholder zeros. For 1 and 51 hundredths, we need 1 placeholder zero. For 2 and 99 hundredths, we need 1 placeholder zero. And for 1 and 6 tenths, we need 2 placeholder zeros. Now this looks a little more lined up and neater. This will help us order. Now we move on to comparing digits from left to right. So we can start putting these in order from greatest to least. So we'll start with the place furthest to the left, and we will work our way right. The place furthest to the left here is the ones place. So that's going to be our greatest place value. We have a 2, a 2, a 1, a 2, and a 1. And since we are going from greatest to least, we want the largest digit in value. That's going to be these 2's. Now, since we have 3 2's, those digits are the same, we need to work our way right and take a look at the 10th place to see which of these is going to be the greatest. So let's look at the 10th place. We have a 9, a 6, and a 9. Those 9's are greater than the 6, so now we have it narrowed down to these 2 right here. So let's work our way right to the 100th place to see which of these is greater. We have a 7 and a 9. 9 is greater than 7, so this is going to be our greatest. So let's write this off to the side. 2 and 99 hundredths. And then I'm going to put a comma here. Now I wrote the decimal from the original list, 2 and 99 hundredths, not the equivalent decimal with the placeholder 0, 2 and 990 thousandths. Now again, those are equivalent, so either will work, but I'm going from the original list. Now we can cross this off and move on to what we have left. Now, before moving on, I do want to mention another way to think about this. We can think in terms of the entire decimal part here. We had 972 thousandths compared to 990 thousandths. 990 thousandths is greater than 972 thousandths. So that was our greatest. Now back to what we have remaining. So we start the process over. So starting in the ones place, we have a 2, a 2, a 1, and a 1. Well, 2 is greater than 1, so we need to look at these 2 right here. Since both of those have a 2 in the ones place, we move to the 10ths place. We have a 9 and a 6. 9 is greater than 6, so 2 and 972 thousandths comes next. So 2 and 972 thousandths. And we can cross this off. And again, we can think of this in terms of the entire decimal part here in order to compare. So 972 thousandths compared to 600 thousandths. 972 thousandths is greater. And now let's continue on. So looking at the ones place, we have a 2, a 1, and a 1. 2 is the greatest here, so that's what's going to come next. 2 and 6/10. And we can cross this off and continue on. So looking at the ones place, we have a 1 and a 1. So let's move over to the 10ths place. We have a 5 and a 6. 6 is greater than 5. So that's what comes next. 1 and 6/10. So let's cross that off. And we only have one left now, 1 and 51 hundredths. So that is last here. And now we are in order from greatest to least. Now that we've gone through some examples together, it's time for you to try some practice problems on your own. So have paper and a pencil ready. So here are your practice problems. You have 5 comparisons, and then for number 6, order the decimals from least to greatest. And for number 7, greatest to least. I'll give you 4 minutes and then we will go over the answers. Go ahead and start. Okay, so that was 4 minutes. Let's go over the answers. So here are our answers. And you'll notice for the comparisons that we're going to start off with here, I have the decimals lined up off to the side. And I have an arrow pointing to the place and digits we were able to use to compare. For number 1, we have 177 thousandths is less than 23 hundredths. For number 2, we have 8 and 40 hundredths is equal to 8 and 4 tenths. So those decimals are equal in value. For number 3, we have 527 thousandths is greater than 526 thousandths. For number 4, we have 2 and 342 thousandths is greater than 1 and 55 hundredths. And then for number 5, we have 1 and 149 thousandths is less than 1 and 191 thousandths. Moving on to number 6, least to greatest here, we have 12 thousandths, then 402 thousandths, then 407 thousandths, then 420 thousandths, and then lastly, 1 and 2 hundredths. And then moving on to number 7, greatest to least here, we have 3 and 9 tenths, then 3 and 77 hundredths, then we have 3 and 728 thousandths, and then we have 3 and 55 thousandths, and then lastly, we have 3 and 52 thousandths. So there you have it. There's how to compare and order decimals. I hope that helped. Thanks so much for watching. Until next time, peace.